He's going to be presenting on how to add artificial intelligence to Python applications. I'm Gabriel. I'm the host of Sin City Programmers. Usually I do a little talk, a little activity, but we're going to try more of a lecture style this week and see how it goes. Thanks. Adam?
Okay, so this is how to AI. It's talking about adding AI to Python applications. There are I think 5 code examples that look a lot like JavaScript too. So if it's not really about a lot about Python applications, using AI and applications is the same regardless of the language. So there we go. There's a lot of stuff we're going to go through. We're going to go through it pretty quick. The first piece is an introduction to LLMs, some frameworks which are going to be Python specific, although some of the frameworks are available in JavaScript as well. Prompting, which is kind of universal. Retrieval augmented generation, again, pretty universal. Chaining and agents, and then fine tuning. So there is.
Is that it?
Come on, you can work. I'm too far away from my clicker thing. There'd be some example code, which is a Flask app. Won't be helpful to you unless you're Python. And if you are Python, you might have been in the thing and saw this talk recently, so you already know what it is anyway. So introduction to LLMs, or large language models. Come on. It's a type of machine learning model that allows you to ask questions in natural language. They require you to translate your language into numerical representation that it understands, right? So if anybody not used ChatGPT? Okay, so you've used an LLM before, and there it went. And you're asking it questions, and those questions get turned into numbers. Anybody here in data science? Nobody? Okay. So yeah, basically it turns into numbers, puts it into this predictive model that says, based on the vectors you gave me, here are the following things that should come from it, which is predictive modeling. But basically they take input from you, turn it into something they understand, come up with a response, turn it back into something you understand. They're language models. They're called large language models, right? There have been language models before, but large language models take a lot of parameters. Parameters are how you tune things, right? So in artificial neural networks, right? These are layers of things that basically you just flip some levers, place weights on these individual nodes inside, or neurons inside the neural network. And for some of the larger ones, you're talking about more popular ones are probably 70 billion parameters, right? So you have a model that has 70 billion weights that are what make it do what it does, right? So if you've ever worked with a company that had data scientists that did any type of predictive modeling, you know they weren't using 70 billion parameters. Because of that, training on that can take anywhere from tens of thousands of dollars to millions of dollars to train it, just for the sheer amount of compute that it takes to do that.
I have an extra. You can use my adapter for that.
We were using 2 different adapters, and they're both getting the same thing.
I'll try it out, definitely.
Yeah,
Thanks for offering. Yeah.
that's awesome.
Helps.
So the first thing about how to interact with a model is you have to prompt it, right? So if you've used ChatGPT, you've asked it a question, but that question isn't actually the prompt that gets sent to the LLM, right? So if you've used, has anybody used any kind of playground for something like Claude or, right? So like in the playground, you can ask the same question you ask it in ChatGPT, it just doesn't work as well, right? So what they're doing is they're taking your input and they're using that to create a prompt. So the prompt is the information that gets sent to the model, which it turns into vectors, and then it determines what it thinks the most likely next vectors are, and then return back what it's going to be.
I think it's just going to stay like that for the whole presentation.
Well, we'll just have to see.
Adopters.
That's fine.
Yep.
We'll see how it goes. Otherwise I can switch it over. And so there are three basic parts of prompting components: instructions, context, and then the request. Right? So you can do it. Instructions tell the LLM what it should and shouldn't do. Right? So you'll give it guardrails. Right? So if you're talking with ChatGPT, well, it actually has a built-in guardrail, like don't talk about kiddie porn. If you're building an application, you probably don't want people to use it for things that are outside of the realm of what you know about. So you may tell it like, I don't ever want you to answer questions about this, or in my particular scenario, right, it's LLMs will make up answers, right, because they know you want an answer. So if they can't find one, they'll actually just create one anyway and think it's perfectly good, because it's trying to guess what the answer might be. So one of those things that you might want to do for the guardrails is tell it like, hey, if you're not 100% sure, don't answer. There's a much more difficult way to have to say that, but basically you're saying the same thing. I skipped over identity. Identity is one of the things, for whatever reason, telling an LLM what it's supposed to be helps it come up with an answer better. All right? You're an expert on X, and it will answer it as an expert on X as opposed to a novice or a researcher or whatever. You can get better results. Input definition, output definition. Here's what input looks like. Here's what output looks like. And processing instructions. There's the context, which is what the LLM should know, right? So if you don't have a fine-tuned model, you're getting into like a general AI. If you're using OpenAI, you're using Google, you're using Anthropic, right? Those are general AIs. They know a lot, well, they know a little about a lot of things. And so you may need to give them, for the subject range that it's going to speak about, you may need to give it just general information, right? I work in insurance, and so I have to give it general information about, here are some insurance terms that you're going to receive that you may not understand. Here's what they mean. Request specific knowledge. So some of the newer models have million or 2 million context windows, 2 million token context windows, so you can send a lot of data, but you probably can't send all of your data. And sometimes sending all of your data, giving it more information is worse than giving it no information, because it gets confused about what you're trying to say. So you may want to give it request specific knowledge that, okay, here's some stuff that you need to know for this particular question that's been posed to you. There's examples, which is also called few shot. So it's giving it examples of, if you were asked this question, this is what your answer would be. And so it helps it figure out what it's trying to do better, where it'll either, you've got the answer. Sometimes you'll give it a few shot because it gives the wrong answer and you tell it what the right answer is. But oftentimes it's like, oh, it can figure out basically like, if I'm asked this type of question, I should give this type of response. And an interaction history. So if you're on a chatbot, it needs to know the context of the previous conversation, because you will likely not respond with, like, if you ask a question, why is the sky blue? And it tells you about Rayleigh scattering, or some other things, right, based on the amount of nitrogen, and you say, how much nitrogen? If you don't provide the previous context, it doesn't know what you're saying. So interaction history is something you provide. And then the request, right, the input from the user. Any questions so far? I know I'm kind of running through this because it's a very large presentation. I try to get through all of it and only get into what people care about. So there's two different ways that you can interact with most models. It's text completion. And we'll talk about text completion because it's easier to see. This is a lot of text. I'm going to make it bigger. But this is all the things we just talked about. All right. There's the instruction section, right, which is includes the items that we discussed earlier. It is what the AI is, right? So this is an AI that you're telling you're an expert on AI. By the way, if you ask OpenAI what an LLM is, the first answer it talks about is insurance. It doesn't talk about models for whatever reason. There are other acronyms called LLM, and it has more information about those than it does about large language models. So if you tell it it's an expert on AI, it'll be like, oh, you mean large language model when you say LLM. What the AI should and shouldn't do, right? You should only ask questions that are directly related to AI. Politely refuse to answer questions about anything else, right? So this is how you keep people focused on the things, because even though your AI can do things, do a lot of things, you may have an application that you want to be focused, and it only does well on a small number of things. This is the information about how to parse the request, on what part does it care about, the information about how to respond, right? I'm going to give you this response. Most of them can respond well with JSON, but if you don't tell them what the attribute should be, it'll just give you kind of random stuff. By the way, just the string, this is a response from the AI, is valid JSON, so it may just do that, which is not what you really want. Getting consistent results are tough. And I hit the wrong button. Apologies. Play, no. I'm a professional, don't have this at home. All right, so we went through all of that. And then your processing instructions, right? It could be super simple, which is how you want it to, how you want it to build its response. Or it could be super complex, like a chain of thought, right? Telling it the instructions on how to process this. First, I want you to figure out this. I want you to take the result of that, figure out some other thing, right? But it all basically is just processing instructions, whatever they might be. So there's the back to the completion text, right? So now we're going to look at the context. So we've told it what it is and how it should work, and now there's the information, right? So general knowledge is the same for every request, right? So this will just be part of a template that you're filling in most of the time, right? So this one, it's explaining what the definition we want it to use for AGI. There are multiple definitions for artificial general intelligence, sometimes referred to general artificial intelligence. We want this particular model to have this definition and understand only this is what we mean when we're talking about artificial general intelligence. Same thing about AI, right? It has a ton of, most models have a ton of differing information about what AI is, because if you talk to a general person today, AI means a lot of different things, right? And so for this particular one, we're telling it always, this is what AI means, this is what AGI means. Yeah?
Just to orient myself, is this the process of training an AI to talk about AI?
No, this is a process of telling an AI how to build a response.
Oh, okay.
So yeah, training is way later. This is just, I have a general AI like Anthropic or Claude or Sonnet or GPT-4 or O3 or whatever your model is, right? It has a lot of information, and if you don't give it boundaries and you don't give it instructions, it'll just do whatever it wants to. If you're building this for an application, which is fine for chat mostly, right? But if you're building an application that needs to use AI, you need something structured, right? I'm going to ask you a question which needs to be about this. I don't have a user going, that's not really what I wanted, I meant this, and then get the right response, right? So if you're doing what I'm doing, which is, all right, I've got a claim in Florida for flood damage that's not covered because we don't cover flood. We cover damage from hurricanes that come in through the roof, not from flood. That is FEMA that handles flood. So I want to deny your insurance claim. I need you to go into the policy and find and cite the actual pieces of the policy that tell me that will explain to you why this is being denied. Right? That's what I do all day long. That's the thing I write. You can't be generic about that, right? You've got to be very specific. It has very specific ways it has to talk. It has very specific things it can say and can't say, right? Because to you and I, damage and damages probably means about the same thing. To an attorney, it is something very different. So it should never mention, when you're talking about damage to property, you should never use the word damages because it is a legal term referring to compensation. So we have all of these restrictions and all these definitions of insurance terms that it needs to understand before it can get an answer, because it has a lot of general knowledge, but not a lot of information about how insurance policies work.
So this training sticks with it forever?
No. Every request you have to send this information. So this is building a prompt. So if you You can train it, right? But what I will tell you is that you'll be able to get on applications, what I found, you can get 80 to 90% of the way there without having to do any training. Training is expensive and requires, more often than not, data scientists. Because training a model is training a model. So you've got to go capture data, you've got to validate data, you've got to create tests, and you've got to split out test versus train. You've got to figure out what your acceptable rate of false positives, false negatives are. Like, when you start training a model, there's a lot more you have to know about. We'll talk about it in a minute. But this is, no, if you just I want to use OpenAI to answer questions or to produce something in a particular way, and it needs specific information to do that, you have to send that with every request. And it's not super hard. You just create a template. Like, always put this in there. Question?
Yes, is there a value I'm kind of like a prompt engineer minimalist.
Yeah.
And I understand like why to get you 80% of the way. But is there value in the architecture? For example, I have Sora and I'm using it for just graphic displays, and I simply said move the sphere across the blue line. And if you set it up in the architecture, is it a thing like, do I still have to over-engineer my prompts, or can I just simply say that I'm not?
It depends.
It works.
So it's from model to model. What you have to do is different, right? Because some models are trained on one set, some models are trained on another set, right? And so they all work a little bit differently, which is a problem, right? Because in the beginning we're like, oh cool, we've got all these model providers, we can just flip between them, right? Like, oh, well, we'll split up this and make sure we're not dependent on one provider. And then like if this one's got a better one, we'll just switch it over. Well, they all react differently to the prompts, so you can't. Version to version, right? Just minor versions. So if you use GPT-3.5 this version versus GPT-3.5 that version, you still have to test everything to make sure it still works. Because how it reacts to your prompt is different. All right? This is the hard part they don't talk about. Yeah. Yeah.
LoRa actually helped with just making these things stick. Like if you just kind of overlay a LoRa on top of it,
right,
and come from UI, something like that. Does that also kind of eliminate the need for kind of over-engineered prompts?
It depends. Again, it depends on so there are a lot of different frameworks and different processes for dealing with prompting. Right. This is kind of very generic, where it's like this is a good place to start. And if you're finding like I'm doing this and it's really weird and it's too much, right? You may need a different model, you may need a different technique, right? We don't have enough time to get into techniques. But yeah, like if you find like I'm over-engineering this thing, and so one question is wrong, another question is right, then it's either do I need a different framework, do I need a different model, do I need to do training?
But you don't want to overfit. That's
right.
Yeah.
And one way that you do that is you give very, very generic information there, and then per request, right, you may do retrieval augmented generation, right? So this was really big before the context windows got so large and you can send so much data. So what we originally had to do is we originally said, okay, we're going to take all of these insurance documents and we're going to break them into sections that seem to make sense, and we're going to store them in a database. Which uses vector searching, natural language searching. And so we're like, okay, find me the documents that are most related to the question that was asked. Problem being is that the words may not be the same. They might not be associated well enough. And it worked fairly well. But if you have it's a good way to find if you have a very large language or a very large domain, knowledge domain. So let's say if you have, an FAQ about how to use Windows, right? That is gigantic. You can't send the whole FAQ every time. But if someone asks a question, you can say, okay, I'm going to go find the pieces that are similar to what they're asking about, and then you think about these things when you do the answer. That's how the request augmented generation works. And so if you ask a question about LLMs, and that's something you have to do with OpenAI, is you have to tell it what you mean by LLM. Because that's an acronym for a lot of things. And the number one thing that's in there is not large language models. And so this is kind of an example of what you would give if you're talking about what a GPT is, right? A generative pre-trained transformer, what deep learning means, right? So I'm not sure what this question was for. I don't remember. But if you pass it this information, it's going to use that knowledge to augment what it does, right? And if you're doing it for your business or an application, right, you're going to give it information that's important to your application to do that. So if you've got a customer that's asking about their bill, you're going to send it information about their bills, right, which you wouldn't store in the model because that's information that changes. If they asked about, weather, right, you'd have to go get a weather report, things like that. Then how do you get the data? We'll talk about a little bit more later. And then examples, right? We're showing the AI how the request and response will be formatted, right? If you have very particular formatting, I have very particular formatting, right? It must be it must look just like it does on the legal document when we cite it. And so we have to give it examples, or it will just not do that for whatever reason. It just kind of comes up with its own thing. And then one thing to think about, though, it provides answers to questions. So that was one of our early bugs, is that we provided an answer to one question, but if you've ever looked at any of your insurance policies, right, they could be very widely varied from year to year or from person to person based on what they selected. And so someone may have this version of this document, someone may have that version of their document, depending on the coverage. And so we had it one question, give it one actual real world example of what the response was, and it went, oh, you asked me this question, I have the answer, I'm not going to look. So it's something to keep in mind that these examples they're called few shots, so it's like you trained it on those 3 answers. Or I guess this one's 2, right? Here's 2 questions, here's the answers. It will always return something similar to what's there. It won't go looking, no matter what data you give it. Well, every model I've used so far, no matter what data you give it, it's going to be, I don't care about the stuff you gave me. I don't care about my large corpus of knowledge. You gave me the answer, I'm going to use that answer. So something to be concerned about if there's more than one right answer, you never want to use that answer in an example. Do you have a question?
Yeah, I have a question. So basically this workflow is going to the opposite direction. So asking a smarter question. So that kind of counterintuitive to the AI concept, right?
It's not that you're asking a smarter question, is you have a general AI.
It's like optimized search engine. Because if based on your question, you get more precise answer, that means just you're optimizing the search problem.
Wait, I don't look at it that way. What I look at is if I ask you a question, right? Like, well, how blue is it? You don't know how to answer that. You have a lot of things that you know are blue, and you know that certain ones are darker, lighter, more blue, more green, more yellow, right? You have this large corpus of information. I've got to help you narrow down what am I talking about. So general AIs are the same way. They have this large corpus of information, right? If you ask OpenAI, what is an LLM? It will, well, I haven't done it in a month. If you ask ChatGPT, what's an LLM? It will talk to you about this other thing that is not large language models because it doesn't know what you're talking about. It's just guessing. And so what you're doing here is you're helping it understand, like, when I ask you these types of questions, these are the types of responses that I should be giving. So this other information doesn't fit into this, so I'm going to ignore it. So you're helping the AI get context more around, like, you're training the model how to answer questions, but you're doing it every single time. So you could do all of this stuff through fine tuning, right? And so it becomes an expert, right? So I think it's almost, if you had somebody who's really good at math and you said, okay, like, solve this problem, but they've got to go through this gigantic corpus of information that they might have in their head to solve it. If you're like, solve this thing this way, it's, oh, well, I can do that really fast, right? I don't know if that helps or not, but it's way more than just kind of a search engine. Is you're really trying to provide, in the context, you're really trying to provide context around the question. And when we're talking about building this stuff, it's normally based on, when I asked it, it didn't answer the way I wanted it to, so I have to give it more context to answer correctly, right? So it can't go ask me 5 questions. How blue is it? And you're like, how blue is what, right? Well, if you've got an API that's got to go generate something using AI, it can't ask you how blue or what, or are you talking about the ocean or the sky, right? It's just got to answer it one time. So you've got to try and give it as much context as you can to give the right answer. Hand?
Yeah, signal that each connection is determined by a weight. I understand what a weight is.
Right.
When you say signal in each connection, can you explain that? I guess connection literal in this case, you mean every time you connect. to the LLM?
So when we're talking about weighting, that was on training, right? So that's training the model.
Yeah.
But on this one, every time you talk to the LLM, you're going to provide it with a prompt, and you're going to have to, in your prompt, you're going to have to give it information to help it understand what you want it to think about, understand how to understand your question, and how to create the response that you want.
Okay, that's what you mean by the signal. And the weight is just implicit in the model. That's it then.
I'm not sure if where I mentioned weight, but weighting is really not in here, unless we're talking about WAIT.
Oh, I mean, literally a sentence. I'm reading it from the...
Oh.
Well, that's a continuation from last slide.
Signal at each connection. Oh, that's right. Yeah, the continuation of...
The vector DB weight.
That's actually like information that was getting passed as the general context. Yeah. I'm just trying. I took this very large thing and tried to break it up into something that you could see. So there's the general info, the definitions, right? Here are terms that you're going to get that you might think are something else. Here's what they mean. And so that's just continuing on. Come on, move. Yeah. So the bold stuff is what we're talking about. But the thing here is like if you have the correct answer to a question, it depends. Never include it in an example. Yes, I talked about that. You can do it. There we go. And then there's the empower prompt again. And then there's the requests, right? So, did I pass over history? Nope, okay. Somehow, the history of what you've talked about before can be in there as well, right? That looks more easy in like a chat completion, which most of them nowadays are chat completions. But the request, how does it work, right? It already knows how to parse what that means, right? Because you've told it up higher. And so you're going to give that information. It's going to know that this is the request because I know how to identify the request because you have this large chunk of text. So it needs to know when are you actually asking a question, which is why you had to tell it how to identify the question. Any more kind of general questions there? Yeah.
This is just for the insurance?
No, this is basically any LLM you're going to talk to, you're going to have to create a prompt. And these prompts are going to need certain things, right, to give you a good answer. Again, if you can give it looser boundaries if it's an interaction. So if you're building a chat system, you can get way looser boundaries because you can ask questions, or you can give this and you can have the question ask a secondary question. But that's not what I build, right? I just build applications that do things and use AI to do it.
Yeah. Just a follow-up question.
Yeah.
The large language model for example, the church, we know it is like Shakespeare, whatever.
Right. Well,
what goes into the large language model for the insurance companies? Is it the contract forms, contract formats?
So, insurance uses large language models for a bunch of different things. But what we use large language models for, and we use just generic large model as a service. We just use that to be able to tell it the adjuster wants to deny this claim for this item with this reason. And you're going to go find the information in the policy, which we give it every time. We give it the information about the policy every time because it's different for different policies. We say, I want you to explain what we're doing, why we're doing it, and cite the sections of the policy where that actually tell it or support that denial. All right, and so the AI gets all the information about the insurance policy. We actually use a chain there where it's like identify the documents that are related to the question. We used to do, it's kind of RAG, but it's really chain. We used to send it to a vector database, but the wording, we got better results just by sending it to an AI. And the AI got cheap enough to do that. And then we say, okay, here's the relevant documents that talk about that. Now we tell the AI, hey, go build this this denial. It's usually like, I don't know, page and a half of text. We're denying this, although your policy provides for X, provides for water damage from sudden and accidental exposure. The damage is not due to the known storm. For penetration from damage, it's from flooding, which is specifically not covered under this exclusion. And then it puts out the exclusion. And puts out what's in the document, perfectly formatted, and other things, right? We also use it to parse non-structured data off of forms. So like insurance uses AI everywhere. Underwriting, risk evaluation, all kinds of stuff.
I mean, my experience when I was working with insurance companies is that they mostly use it for rating release because it's their business model.
Right.
It's their business.
Right, so that, yeah, but that doesn't necessarily, they're not using LLMs for that. They're using specially trained,
It's a machine learning.
yeah.
Because constantly looks into the averages paid, zip code,
Right.
address, how many addresses, and so
Right, and that's not just insurance, right? So that's, everybody wants a score, right? So I used to work for TransUnion. TransUnion has a credit score, which is a model. Well, it's based on a bunch of models, but there's fraud models, right? So that's kind of like the previous iteration. These are models that take a very specific set of inputs, right? You're getting a vector of a particular type with particular data that's sent in there that it's expecting, and it understands the data. It doesn't have to figure out what the data is. It knows I'm going to feed you this information. You're going to feed me back a number. And so that's kind of a pretty standard machine learning thing. An LLM is, I'm going to give you just a bunch of junk. You're going to turn it into vectors, and you're going to tell me what comes next. That's what is predictive modeling. So it's going to return what it thinks comes next, which is the answer to the question that you asked. Or if you start a sonnet, it will complete the sonnet, right? So it's only giving you an answer because you asked it a question, and what logically comes after a question is an answer, if that helps. Just something?
No, I'm just thinking that the goal of the insurance company is to deny the claims.
Well,
So first of all, they're taking the insurance policy and training the AI on the policy. And
well, we're not, right? So we can't do that, and
they're training it to assess the claim.
no.
No.
So the adjuster is the licensed individual who can assess the claim, right? Every insurance company that we've talked to does not want that because there are problems with that, and there are liability issues with that. But no, with our system, it's a menial task that is annoying to the adjuster, which is I need to go through this policy and find all the places where I can defend in court my reason to deny this. Right, so we're just going through and they're saying, I'm denying your floors, baseboards, and walls for flooding. And then it will go and create proper language around that based on what's in the policy and the actual citations of the pieces in the policy that support denying your floors, baseboards, and drywall for flooding.
Okay. So we take the existing policy and train the AI.
We don't train the AI on the policy because policies are different so that's why that was brought up more in the request level, because every person's policy is different.
But once you have an AI model, you can then adapt the policy to increase the denial.
Well, they don't use AI models to do that, right? So basically, as a policyholder, and not defending policy, like the insurance industry, right? But the way the insurance industry works is, you can buy a policy that will never deny anything. You probably don't want to pay that much money, right? So they consistently adapt policies, which is why we have so many versions of them, which is why we have to send it with every request, is based on what your particular risk profile is that what you're willing to accept and what you're willing to pay determines what forms and endorsements are in your policy. So many people have different opinions of the insurance. I'm from a non-opinionated version. Like, they're adjusting what they're willing to cover based on what you're willing to pay. And so when it comes through, if they've got to pay it, they've got to pay it. And especially when you're talking about things like in Florida with hurricanes, they have 60 days. They have 60 days to get to your residence. They have 60 days to get enough professionals out there to figure out that is the damage caused by something that we cover, If it is, how much is it going to cost, right? Because they go through the whole estimate model, and then you've got 60 days to figure it out and get it paid. Like, yeah, make a determination within 60 days. Which is one of the reasons that our tool was so useful to them, is because there's this mundane thing that takes 30 minutes. I've got to go through the policy. I know this is denied, right? Unless you have a special rider on your home insurance policy, you do not cover flood, right? There's the National Flood Insurance, and that's what covers flooding, because insurance carriers don't do it. So, but where it's in the policy and how it gets denied is different from policy to policy to policy to policy. So even though they know there is no way this is covered because it's due to flooding, there's no holes in the ceiling, this is flood damage. They have to go through that document, which is hundreds of pages, and find all the different places where it says we don't cover this for flood, we don't cover that for flood, and find where it's talking about the thing they want to deny. So the AI is not making the intelligent determination, it's just doing the mundane crap of going through this policy every single time you need to find out why they want to deny it, and most of the time you're denying multiple items for multiple reasons. So it could be this large, arduous task.
But the underwriters could use AI to assess the risk of an individual before.
Well, underwriters are using machine learning models, right? So I wouldn't call that, like, then again, like when you ask somebody what is AI, like when I think AI, I think LLM, right? AI is kind of like a blanket term. So large language models are the things you ask questions and get answers from. Machine learning, right, or other types of kind of lower stuff. There's deep learning and machine learning and AGI and all this type of stuff. But what we're specifically talking about here is large language models. Yeah.
Before you feed the policy, do you prompt the AI in a way that you found makes it better at reading the policy, or do you find that the off-the-shelf LLMs are fine at understanding your requests and, given the context of?
We did have to give it specific information about how to return the response, because it can read it okay. It reads it better than you would expect, because I don't know if you've ever tried to actually get the data out of a PDF. The data's not as well formatted as you might think, right? Because when you visually look at it, it makes a lot of sense because things are indented. PDFs don't actually indent, there's just text, right? And so all that gets lost, and the LLM's actually amazingly good at doing that. But it's more on the, how do I want you to formulate your response? And you may want to give it information about, I want you to focus more on this than that, because there's a lot of language, right? There's a lot of very, very, very lawyer speak going on inside of those things. So it's actually pretty good understanding. But it's not to the point yet where we could tell it to, we have hopes to at some point, like say, here are the things that were damaged, here's the sections of the policy that say they're not covered for these reasons, is this valid, right? Because when you're making the determination, you actually have to go look at photos, like sure, 10 years, maybe AI will be doing that stuff. But there's a lot of information you have to take in on making that determination. You have to look at photos and say, this is not indicative of water damage from penetration from the roof. This is indicative of flood. Or this is mold damage that's not covered. Or this is repeated seepage and leakage, which is not covered. So there's a bunch of stuff to that where the AI is not doing in insurance today. Probably will at some point, but it's not doing that now. I'm just trying to use kind of allegories on like, here's the things I understand where it's a very complex thing, and you could do extremely complex things, and it does it at a way that will just blow your mind. Right? So if you need to add AI to an application, the first time you do it, you'll be like, oh wow, I didn't know it was this easy. Now when you start finding edge cases, it becomes more problematic. Right? So a lot of the things you're changing with the prompts, it's the edge cases, and we'll get into that more too. Chat completion is basically the same thing as text completion, except it's just you break the pieces up, right? So there's the system message, right? And the system message, right? There's a system message. There are the interaction history, because we talked about the interaction history, and then the question, right? And so the entire prompt where you provided everything else that was not the history and the question goes into the system message. Depending on your model, you can break it up into multiple system messages. If you're using a reasoning model, the role names have changed.
I was gonna say that.
Yeah.
Developer message now too. 'Cause
Yeah, there's developer message instead of system message. But basically, you're going to just give it all of the information that is not the history and the content, and it makes it easier for it to figure out the history and the content. That's all. Temperature. So temperature is the level of randomness, typically from 0 to 1. All the models I've used is from 0 to 1. There we go. Where 0 means I don't want any randomness. So the results will be very similar. Maybe not the same, sometimes the exact same, but it's going to be very similar. So on temperature 0, why is the sky blue? Right? And again, so temperature 0 is good for expert applications. So I use temperature 0 because I'm not talking to people. I'm not presenting them with visual responses. You know, when I say, why is this thing, find me the reason why this item is denied for this reason, it has to be the same every time, or people get like really upset. So if I ask it things for, come on, there we go. Why is the sky blue? And we set the temperature to 0. The first output comes that way. So if you ask an AI, it may ask you something similar to this, talking about ray light scattering and the Earth's atmosphere and sunlight and nitrogen, blue light, that type of stuff. And it looks pretty presentable. And if you ask it the second one, it will either be the same or nearly the same. So temperature 0 is that. Now temperature 1, right? And one thing to understand is that what the model behind the scenes is doing is it's finding all the possible answers and then giving internal confidence levels and say, aha, I'm going to select the one with the highest confidence level. Well, if you have 3 answers that are similar confidence levels and you don't give it a temperature 0, it'll just say, well, one of these 3 is fine. So I'll return first one, the second one, the third one randomly. And so you do the same thing, you ask the same thing, the first question comes back that way, ask it again, and it could come with something very similar, right? So it's a very similar answer, but the details of why it's blue are different, right? It's the same answer told a different way. Both of them are correct, right? Just somehow the model decided that on the 0, right, that this is the most correct, so I'm going to return that one every time. And your application may have something in the middle. I think the default on OpenAI is like 0.75. But if you're building something conversational, you don't want to spit back the same exact thing every time because it sounds like I'm just looking and giving responses back from a FAQ and I'm not very smart and I'm not very engaging. All right, if you're building a customer service helper, you want people to feel engaged. You don't want them chatting with an individual. You don't want them making a phone call. You don't want them starting a chat with a human. You want them to use this as much as possible and you want them to enjoy it. So making it more conversational, the higher you raise the temperature, more it doesn't sound like they're just parroting something that makes people annoyed. Any questions about the temperature stuff? Yeah.
Does this also incorporate the top being ability, or are you about to be in?
Well, a lot of them don't offer that anymore. Right, because there's a lot of stuff that used to be offered, because like OpenAI used to be able to get back the actual, it would tell you what the confidence level was. They don't do that anymore.
Really?
Yeah, and now that so more models nowadays that they're coming into a mixed model where it's basically like just a front end of ChatGPT, because ChatGPT is not a model. ChatGPT is a system that uses a model, and it alters things and it makes multiple requests and it changes what it does to make it better than just a model. Nowadays, what people are moving to is to the reasoning models. And so, like ChatGPT 5, there will be no more O, right? O4 is dead, or actually O3 non-mini is dead. Right, O3 mini came out. O3 will never come out. It will be ChatGPT 5, or it will be GPT-5. Claude's doing the same thing, right? They're all doing this. Is basically everybody wants these super smart things, and so you'll just send it all to one API endpoint, and I'll figure out what I have to do from there. So unfortunately for people like me, right, that means it's more complicated to get the right answer. It's more complicated to get a trained version of that. So you're getting less and less. So these are the things that are always available. Like temperature, I've never seen one where temperature wasn't available.
So it's less control than over the penalty at the top for a student.
Right.
Got it. Just making sure.
And he was bringing up the data sciencey stuff, by the way. Retrieval augmented generation. So requests are limited to thousands of words. In the most expensive models, 1 million words, ish, right? They're tokens, depending on how long the word is, how much punctuation you have, right? It's about there. But it's not, most corpuses of information, it can't contain the whole thing in every request. And again, knowledge domains are typically very large, right? So in my circumstance, right, if I look at every single insurance document that can exist, it gets actually even more complicated with that. Let's not use insurance. But if we say like, I want help for Microsoft Windows, right, that's a very large corpus of data. When you're talking about all of the manuals, all the FAQs, all the chat history, everything on Stack Overflow, right, that's how you get good answers, is you do all of that. That's very large. So retrieval augmented generation is a way that you can provide the right information, right size your information. That's another thing you brought up. If you give a model too much information in your prompt, you can confuse it. So if you give it unrelated information, it's like, whoa, here's all this other stuff I got to think about that's not related, right? So it's like if somebody asks you a question and goes on a 15-minute diatribe about, and 99% of it is useless to you, right? You're not likely to be able to get the right answer, because you've got to just sift through all this other stuff that's not related, but you think it might be, because you don't know. And so it allows you to do that. And training and fine-tuning is expensive and time-consuming, right? So if you're just using an AI for your application, right, having to get into the fine-tuning part and the training part, you now get in the world of like real data science, or you're creating problems for yourself. You either have to like get better at the data sciencey part. You don't have to become, necessarily understand the math and all that nonsense, but you have to understand the process of training a model. And that is expensive and time consuming. If you have to hire a team of data scientists, that is really expensive. And it's a good stopgap, right? So this is a really good stopgap until you've proven, like, again, the way that I work with this is like, I can get 80% of the way just through prompts, right? At some point, I'm gonna have to do prompts in RAG, right? At some point, I'm gonna have to get beyond that, because my users are like, 80% is better than humans, way better than humans. So we like this, but in a year or so, they're gonna be like, this thing's wrong 20% of the time, right? Because you've changed normal, right? It's like, when I grew up, you couldn't just reach people all the time, right? I'm an old-timey guy. We didn't have cell phones. And now, like, just not being able to immediately get in contact with someone at all times of the day or night is just weird, anywhere on the planet, right? To not be able to order something and have it show up that day or tomorrow is like really weird to people nowadays, but at one point it wasn't, right? So expectations have changed, and expectations of my users are going to change, that being right 80% of the time isn't going to be good enough. So I'll have to find some other way to make it better if the models don't. So far, the models getting better have increased my accuracy rate enough that I haven't had to do it, but it's going to happen at some time. I just know it will. Also, if your knowledge domain changes regularly, right? If you're constantly having new FAQs or new information, and you have to train every time you get new information, that's a problem. So if you have a dynamic knowledge domain, you're going to want to use RAG anyway. Because you probably don't want to train it every day or every other day. And it allows you to provide refresh data as it happens, right? So if you have an account assistant, right, it needs to know that what's real time, what is the account data, and that's request augmented generation. And even if you can fit everything in and the model can do it, if you've seen the pricing per request on million token models, you may not be able to afford it, right? Your business case may not be able to afford the fact that every time I ask it a question, it's going to cost me $12. Some may not. But if it is too expensive, then you can bring that down by using some sort of solution to augment the request with just a small amount of data instead of the entire bit of data being sent. Talk about that. And again, and it's the same thing like he was talking about, like overdoing the prompt. Every word you send costs money. And in the newer models, every time you tell it to think about something costs money. If you give it chain of thought, every time it comes up with an interstitial answer, that will cost money too. But let's not get into that. Just kind of like standard AI models, everything you send costs money. So RAG helps you optimize costs by sending less data to answer the question. And where that normally gets solved is through vector stores. So is anybody familiar with like an ELK stack? No? Elasticsearch? Okay, that makes more sense. Yeah, that's the E in ELK. Yeah, that's Elasticsearch, Logstash, and Kibana. So that's how like people feed giant systems. They feed all the logs in, or if you're using, I can't remember their name now, the ridiculously expensive people who aggregate all your logs. Nobody? I can't remember their names, but it's text search, right? So you're finding what's that? No. They're actually cheap compared to the other ones. I can't remember the name of the company, but they were like one of the first ones, and they charge you like $1 gazillion. And all they do is they just like suck in logs.
Let me get a chance. I got a real nerdy question about vector stores. I'm hoping that you
Yeah. So vector stores are basically how you store data in query using relation functions. Vector databases, right? So if you've searched stuff on Redis or Elasticsearch, you've used a vector database, right? If you've done a full text search anywhere else, you're probably also using some sort of vector index, right? So if you have like, if you're using Postgres and you have a full text search on a field, that's also making some sort of index using a vector index. So if you do things like, this is Elasticsearch, like find me the top 5 documents that match this type of text or similar to this other document, it's doing the same thing. So when you use this inside of AI, for the most part, you're using models to create the embeddings. So you're basically turning a large piece of text into smaller pieces of text using some sort of model. And those models are available as services, right? So they may store the link to the actual source data, or they may store the source data itself. It depends on the database. But they need vectors, right, to index. So you vectorize your knowledge domain. And then you vectorize your search criteria, and you send it to a function, right? So when you're storing the data, right, you're going to send it documents to a model. It creates a vector, sticks in the database. When you're querying, it takes the request, sends it to a model, gets the vector, and then, right, k-nearest neighbor is one of the most popular functions that you can do. Send it to the vector store, which then finds the documents that are related. Apparently this k was 3 because it returned 3 documents. Most languages have some sort of library to do this. Use the library, try the defaults, maybe mix it up a bit. If you're not a data scientist and you don't understand what's the difference between the 18 different functions that are probably available in your system, right? You can try to switch them around and see what gets better results, but then you're getting more data sciencey again, right? Because how do you know which one gives better results? How large was the data set that you used to verify it gives better results? It's complicated and weird. K-nearest neighbor is like the most popular one. And how you vectorize your data can make a difference because you're using models to vectorize that large amount of text into a small, consistent vector. And it's identifying what words are important. So if you need to tune this, changing the function that you use or changing the model that you're using to do vectorization can make a difference. But if the default solutions don't work for you and you're not a data scientist or play one on TV, you're going to have trouble. Which is where it comes to chaining an agent. So one way to not have to do vector databases is you can do chaining. Chaining creates a pipeline, right? So I've got the result of this, goes into the next one, goes into the next one, goes into the next one. So instead of doing vector searches, right, what we do is we're like, okay, I'm going to send out 20 requests for the 20 different documents to a model and say, I've got this question, does this document relate to it? Instead of having to do k-nearest neighbor because you use this industry term, right, that's used by people, and then on the document there's terms used by attorneys, and they don't usually match. But an AI is smart enough to figure it out most of the time. So we've gotten way better results getting rid of the vector searches for request augmented generation, and done chaining instead. So we have step, model process, and then the next step, model process, the next step, model process. Because oftentimes, when you give it too much information to do, now let me back this up, this is non-reasoning models. Reasoning models are new, reasoning models are expensive. So if you're putting this in your application, unless you're doing something where you're charging a lot of people to do research, you're probably not using reasoning models. And so you would create a pipeline, right? So this is ours, right? Are these documents relevant? Send it to the model, and then we send those documents to the model and say, now make a response, right? We have a fairly small-ish per request domain, right? Because it's just one policy. But if you're trying to say, like, how does Windows work, right? You can't send all of that to a model. You're probably going to have to use like standard vector databases for RAG. But creating a chain can help that. And in our current ones, there's actually 2 different model calls in between there. So there's in the industry, there's this divergence, right? It's like some systems are way better for tiny, tiny things. You ask it to do very small things, and you can use very small models that respond very quickly, and you can chain it. And some of them you get really complicated models, and you send it a really complicated question, and it works better there, right? So these are just kind of different options that are available to you of like, I sent it to this big, giant 70 billion parameter model, and it just doesn't do well. But I can't afford to send it to the 70 billion parameter model for the, every request. And like, oh, well, maybe you can get by on a 7 billion parameter model and ask it 10 questions, right? So there are options. For breaking up complex stuff, because that may be the best way to do it. Reasoning models may change that, but for most of us, reasoning models are just too expensive. And agents are also available in a lot of the reasoning models, or the ability to do that is available in the reasoning models. And agents are basically a part of a chain anyway. If you ask ChatGPT to do something, like I want you to get me analyze the headlines in the New York Times, it's performing a chain that says, aha, go get the current things from the New York Times using an agent, and then I'm going to synthesize the information from it. Something like this, right? So you have a problem that you need solved, you send it to the model creates steps, and to solve that problem, that will they'll have instructions for the agent, right? So go, have an API to the New York Times. I need you to call the New York Times and get the 10 most popular articles of the day. It comes back, it feeds that back into to a model and completes it. Or you may ask it, hey, go cancel this appointment at this time. It understands what you want. I've got a connection to Google Calendar or whatever calendar you use, right? And it makes an API call inside the system. So agents are, this is the real popular stuff that you hear about in the news all the time right now, because now you can just be like, hey phone, go do this thing, or whatever, right? Where it's interesting for us, for what I'm building, is that in that chain, I can create an agent that says, oh, hey, go get these documents, right? So I can find it like, here's the information, here's the basic part. I'm writing a lot of code right now to mimic what a desk adjuster would do to solve this problem, instead of just telling an AI, here are your resources, solve the problem, right? And it comes up with a solution to solve the problem, and then we go use agents to go execute those steps, and then it solves it. One of the big advantages I see for that is that different insurance companies want it solved different ways. So I've either got to code how to do that, and give them options or give them these horrible workflow builders. If you ever worked in one of those systems that has a workflow builder, you never want to see them ever again. One of the problems with building systems that are infinitely modifiable is that they're infinitely modifiable and infinitely configurable. So having the AI as part of either a fine tune or a prompt, right, be told to solve it in different ways based on what that particular customer wants, there's a lot of advantage to that if you can do it well, which is where I see the big thing for the agent stuff. Any questions on that type of stuff? Yeah.
So are agents models themselves?
No, agents are just things that do things outside the model.
So why don't we just call them integration, API integration for support for them?
It's more than an integration, because integration means that I know what my request is, and I'm going to do something very specific with a response, where when you're doing agents in a chain, it's that the model needs to do something. It needs to come up with an answer. In order to get the answer, I need this other information. So it has the agent go get it and come back. An agent is a wrapper around an integration, right? So that the model knows how to speak to the agent, because it's going to create a command. Often, like if you've, so there's this, one of the popular ones in Python is called swall agents. And they basically say, hey, and I mean, agents was the first thing I actually got into in AI. And that was the whole new thing of like, I'm going to be able to tell it, hey, go figure this thing out for me. It's going to go do stuff, and it's just not that easy. But the agent is a way that your system that's using the model tells it, here's how to instruct me to use this integration.
So do you just write agents in plain text that describe to the model as you would a human, what the schema is, what the endpoints
You usually don't get that. Basically, it's like, here are the things that are available to you. You can ask me what a current stock price is.
Okay.
I need this information, I'll give you that information. Right? So and here's how you tell me that you want the current stock information. So you're basically giving instructions on how to respond to you so that you can then call an agent. Like swall agents basically just creates Python code. Like, here's the Python code you would need to do this, but it's very simple and it's really scary that an AI is building Python code that can just run. But when I've done agentic stuff, it's like, give me the information, I'm going to tell you I need this information from this thing. So one of the first things I built is creating multiple knowledge domains so you get better answers, right? So you go to a chat thing and you say, I have a question about this, and then an expert on that topic would respond. But you have to figure out which has the right topic, and that expert might need external information, right? So you're just creating this way to talk to the model so that it can give you the instructions you need to interact with your integration. And if you talk about it at a more reasoning model, some of them have these things built into them where it's just part of the system. It's not something you're building the integration for.
Progress question, if I could. Is it bad practice to put these models in the loop and have them work asynchronously, just because we're in the agentic part of the conversation?
I would argue that a loop is more often better, because one of the problems with the stuff that exists today, right, is it comes up with the plan and never alters the plan, right, based on the data. Like, so it's almost like telling somebody like, here, unskilled worker, here are the instructions on how to do this, right? If something goes wrong here, you're not going to be able to react to that. You still have to follow the steps, right? And that was one of the things when we did our research. This is a problem, because what we want to do is we want to just create this loop of like, go get information now, what's the next step? Go get information now, what's the next step? Because the next step could be different based on information you've gotten during the process.
So it's not frowned upon. They're not going to think I'm making a rogue AI, or I'm not going to violate any AI.
Most AI vendors don't care as long as you don't exceed you're not doing things that are not allowed by your terms of use, and you're not exceeding your quota. They don't care, right? You can call us 1,000 times. We're just going to charge you every time. Yeah.
So you're saying like the agent typically would loop back to the solved problem, and then it would make sure that like it did what it's supposed to do, and that's the loop you're talking about?
Well, so what happens is, solve problem, right? Solve problems comes up with the instructions, right? So you're going to come up with a plan. So as an AI, I'm like, okay, you asked me to do, you asked me to figure out what the latest news is or whatever. That's probably a terrible thing, but that's insurance, right? You want me to deny this, right? It's going to go through and find the instructions. Okay, I'm going to go here. I'm going to pull up your documents from the external API. I'm going to pass those into this thing. I'm going to do this, and I'm going to do that. Problem is what if it comes back and it's like, oh, you shouldn't be denying this, right? Because everybody makes mistakes, right? They have a special rider that actually covers it, right? The system isn't going to take that into consideration. It's just going to keep going, right? It doesn't go like, oh, I've got this new information that, oh, this has a specific document that actually allows this thing. So I should change my thing. Instead of generating a denial, I should generate a payment. So it doesn't react to information. It gathers as it goes. It just creates the plan, gathers the information, and does the final step.
But what I'm saying is, doesn't it go backwards? But a lot of these models I see, these agents, it's continuously going back to the model and like iterating.
Well, the agent doesn't go back to the model. Well, yeah, there's a controller, right, that is going back. It depends on how it's built, right? What I'm talking about is like most of the agentic libraries that are out there, right? They're going to go get its marching orders and then execute the marching orders and be done, right? There's no way for it to send something else to the model that was not part of the original piece. So it's not acting like a skilled worker. It's working like an unskilled worker. I don't know what I'm doing. I'm just told I press this button, I hit that button, I hit that button, I hit that button, I hit that button, in that order. All right. If you hit that button, an alarm goes off. You don't know what to do, so you just hit the next button, next button, next button, next button. Right? Yeah.
What are like some good approaches for the base case for your agent to like exit, basically?
You're going to have to. The AI needs to know that that's an option and build it into the plan. But like I said, it's building agentic stuff. If you do it by hand, you can do all of the stuff that we're talking about. Like you can iterate over things and pass the back stuff. But if you use like a lot of in our most recent, and all this stuff is very new, right? In our most recent investigation, is that these things aren't that smart, and they just create a plan and then it just follows the plan. When you're using like an agent library, it says first thing it does is here are the things I'm going to, I have these functions available to me. I'm going to get their definitions, include them in my request, send them to the model, tell it to build a plan. It builds a plan and then it just executes on them one at a time. So it's just a drawback in the libraries that are available, not in what you can do with agents.
Okay, so I guess like should you, when building an agent, like limit the number of retries or what to do and an error so it just doesn't continue? Like almost like a base case.
It really depends. Like I've gone, my application would be in really bad shape if it didn't automatically retry when OpenAI wasn't available or when AWS TextRact just shat itself. Right, it's those retries that keep my system alive, because if you've ever used OpenAI and subscribed to their status updates, bad things happen all the time. But they're just like, and their answer is it's not down. We just have increased error rates. So retrying, sometimes it works fine, right? So it depends on the situation. But if you're just trying to, like, there are some like out-of-the-box solutions where I can just make it do stuff without having to really understand how it works and how to change the prompts and how to get that going. There are limitations to that, right? An agentic approach, you can do whatever you want and build in all the things you're talking about. But it's not really, again, a lot of these libraries are just brand new, right? Agentic stuff is like from the very beginning, it's maybe 2 years old. When people are like, I'm going to go tell AI to do something and figure something out and do stuff. That was like maybe 2 years ago. And so there are some really complex libraries that are really hard to use, and there's really simple libraries that are super easy to use, but they have a lot of limitations. How are we doing on time? Got like 4 minutes? Over? Okay. Yeah, because the last part, like fine tuning, I just want to get really quick into this. So fine tuning, right? It's just, you're basically putting a layer of your domain-specific stuff on top. Oftentimes it's done using a layered system. So when you train a model, fine-tune a model, they have just your piece of fine-tuning that sits on top of their model. So you don't have to pay for the whole model when you run it. But let's get into this stuff. We'll just say that. It's moderately expensive and requires a lot of knowledge. For you to train the model, you have to know if you're training it correctly, which requires a data science mindset. Right? How do I test this thing from a large corpus of data to ensure that it's going to work correctly? What I'll also tell you is that any AI application you build, you have to actually start generating a data science mindset, because you're setting something off to this third-party thing that thinks, And you have to make sure that it thinks correctly. And how do you know that it's doing that? And how do you know that over time, right? Data science terms, how do you know you don't have model drift? Right? I have a whole talk on testing. Because once you start getting into models, they start looking great, but you have to start thinking about like, well, what happens to my users when this happens and when that happens? And creating, making sure it works right on edge cases and non-edge cases, where what we're used to doing is when I give you A, you give me B, and I verify that you give me B when I give you A. In a model, it's going to give you B prime 1, B prime 2, B prime 3, B prime 4, right? Depending on when you ask it, it could answer something completely different. Asking it the exact same question, it can give you multiple different answers, and one of them you might not like. So, and I will finish there because we're over.
Very cool. Very good.
Just glad it lasted for the whole time.
Yeah, cool. Well, thanks again, Adam. I think it's been really insightful.
Sorry.
Yeah.
Oh, no problem.
Thanks everyone for coming. Feel free to hang out. But that's officially the end.
Right after that.